radical expressions and radicals to fractional exponents. So we're going to simplify this. This should look partially familiar, all right? We did just adding these two pieces. Now we're just subtracting or adding one more thing, okay? So we're just going to simplify radicals. We're going to get really good at these. So the first thing we want to do is the 3 goes in the top, right? And we just write this as the square root of 5 over the square root of 2. And then we're going to simplify this piece, square root of 2 over square root of 5. And let's start simplifying the square root of 90. So 90 is 9 times 10. And we can take out a what? Okay, square root of 9 is 3, and that 10 stays inside. All right, and from what we were doing before, we want to simplify this by rationalizing the denominator. So, Caden, what should I multiply top and bottom by here? Okay, so square root of 2 over square root of 2. And here, square root of 5 over square root of 5. Over here, we do not need to rationalize the denominator because that's over 1. Okay. So this is 3 square root of 10. Be careful. A lot of people actually miss this on the test. They put 4 for that. Okay, that's the square root of 4, which is 2. All right, and then here we have 3 square roots of 10 over 5 minus 3 square roots of 10 over 1. All right, now Chloe, when we add and subtract fractions, what do we have to do here? Yeah, we need common denominator. So I'm going to multiply this one by 5 over 5. And I'm going to multiply this one by 2 over 2. And what should we multiply this last one by? We need 10. So 10 over 10. Okay, these numbers multiply to the outside numbers, not the inside numbers, because they're not radicals. So I have 15 root 10 over 10 plus 6 root 10 over 10 minus 30 root 10 over 10. And now we have all common denominators, and we have all root 10s. So because of that, they're like terms, we can add the tops. So what's 15 plus 6? 21. What's 21 minus 30? So negative 9, and we keep the root 10 over 10. So we just add the numbers in the front. Okay. Do you guys think we need to do another one of these? Are you guys good if there's like this number in front? I mean, you just multiply whatever you take out times that. Okay, I feel like we're good. Okay, this is also new, so take good notes on this. Radicals to fractional exponents. So we're going to rewrite this. So here we have square roots. So do you guys remember what fractional exponent a square root is? It's the same thing as what power? Nate? Cute? Squared? No. The kind of the opposite of that. So the square root, you guys, is the same thing as the 1/2 power. So I'm rewriting this one on the inside here. So just this one on the inside is the same thing as 7 to the 1/2. Now I have this guy on the outside. I'm going to put that here. And this goes around the whole thing, right? This square root. So I'm going to put another big set of parentheses and that whole thing to the 1/2 power. Okay, so change the radicals to exponents. Now, whenever we have this power on the outside, this always multiplies to every power on the inside. So this 7 has a 1 on it because there's no exponent, and the 1/2 that's on the outside is going to multiply to each of these. So now I have 7 to the 1/2 times 7 to the 1/4. Okay, so that outside one multiplies. And then this is like having x squared times x to the 3rd. What do we do here with the exponents? We add them. So now, same rule here, because there's no more parentheses, I already distributed the power on the outside, we just add exponents. So I need a common denominator. 1/2 is the same thing as 2/4, right? So I just changed the 1/2 to 2/4. And now we can add exponents and keep the same base. So 7 to the 3/4 power. All right. Ooh, that one looks fun. Whoops. Okay, so I have the cube root of 3 and then the square root of 3 embedded inside of that one. Start with your inside first. So I have the square root of 3. So the square root is the same as what power? What do you want to memorize? Same as what power? 1/2. Okay. And then we have the 3 on the outside. And I've got the cube root. Cube root is the same as what power, you guys? Good. And that 1/3 or cube root goes to the whole thing. So that has to be on the outside of the parentheses. Again, this is a power, so it multiplies to each power here. There's a 1 on this one. So I'm going to multiply the 1/3 to the 1, and we get 3 to the 1/3. And I'm going to multiply the 1/3 to the 1/2, and we get 3 to the 1/6. Okay, now we just add exponents, just like we did before. There's no more parentheses. We're just multiplying, which means adding exponents. 1/3 is the same as what, so that I can add these? Yeah, if you just want to kind of cross it out and write 2/6, that's fine. So I'm adding the 2/6 and the 1/6, which gives me 3/6, which is the same thing as 3 to the 1/2. All right, this last one does not have embedded ones, all right, which means that like this radical stops. It doesn't have it like inside there, okay? So we're going to rewrite each one if there's exponents inside. So this right here, cube root, is the same thing as what power, you guys? 1/3. Okay, and that cube root only goes to the x to the 5th and the y to the 3rd, just that first piece there. All right, and now we have the 4th root. So the 4th root is the same thing as what power? What do you guys think? 1/4. So 1/4 goes on the outside of that guy. Okay, these are both powers on the outside of the parentheses, so both of them have to multiply to the inside powers. So 1/3 times 5 is 5/3. And what's 1/3 times 3, you guys? 1. Okay, and drop the parentheses after you multiply. So now this is going to multiply to each of these. There's really a 1 on this x. So I get x to the 1/4, multiplying it, and y to the 5/4. Now we're just multiplying, so we add exponents, all right? There's no more parentheses. You should always drop them after distributing here. And now we add exponents. So these two right here, we have to get common denominators, right? So for the x pieces, I'm adding 5/3 and 1/4. I'm going to write that off to the side, right? So that's out of 12, so that I can add those exponents. Multiply this guy by what? 4. Multiply this guy by what? 3. So I add the top, so I get x to the 23 over 12. Okay, and same thing with the y's. We're going to add the y exponents. Ones are a little bit easier. What can I change 1 to so that I have a denominator of 4? So I'm going to write it right here, 4/4. So I'm adding 4/4 and 5/4, which is 9/4. Okay. Always reduce at the end if you can on those fractions. And I think we're good.